For this test 3 wrapper, I decided to do problem 2 from the test because that's where I had the most trouble. I somehow decided that the electron current of H plus equaled the electron current of SO4 2 negative, so I only calculated one of the one of the currents. So that was wrong. So I'm going to go through the calculations and show how it's to solve this problem. On the side I wrote down all of the knowns that we know in the problem. So we know the electron density for SO4 negative. We know the drift speed of H plus. We know the drift speed of SO4 2 negative. And we know the cross-sectional area. So from this figure, we know the electric field is going over here. We have a positive charge on H plus, so the electron current is going over here, this way, to the right. And then for SO4 2 negative, it's a negative charge, so the electron current is going over here. So since we have all the information for SO4 negative to negative, we are going to solve that one first. So all you do is you use the formula from the formula sheet for conventional current. I equals the charge times N, which is the electron density, times the area, cross-sectional area, times the drift speed. Since there are two charges on SO4 2 negative, we have to multiply all of this by 2 because for the charge it's 2 times that. So it's 2 times 1.6 times 10 to the negative 19 times N, which is 4 times 10 to the 25th, times the drift speed, which is 2 times 10 to the negative 5, times the cross-sectional area, which is 2.4. Copy this down wrong. 2.4 times 10 to the negative 4 meters squared. So you punch that all into the calculator, and you get 0.0614 amperes. For the I of H plus, it's basically the same thing. You do Q and A V. The Q, we only have one charge, the plus, so it's 1.6 times 10 to the negative 19. And then for N, we know that there is 4 times 10 to the 25th ions per meter squared, and there's negative 2 charge on that. So if we just times it, that would be there's 2 times as many protons, H plus, floating around per meter squared. So it's just going to be 2 times that number. So 2 times 4 times 10 to the 25 times the drift speed, which is 9 times 10 to the negative 5, times the cross-sectional area, which is the same, to the negative 4 meters squared. And when you plug that into the calculator, you get 0.277 amperes. So now you just add them up together. H plus, and you get 0.338 amperes. And we know by the electric field and all, and H plus, that it's going to go to the right. And what a stupid way to lose points. But anyways, that's the whole gist of the problem, and that's all.